right, girls. Today we're going to talk about the perimeter and area of similar figures. Remember what similar figures are? Okay, somebody want to volunteer? What's a similar figure? Are these two figures similar?
Yes.
Why? Same what?
They're the same shape.
They're the same.
Size. They're not the same size.
Okay, let's make sure we understand what similar figures are.
They're just similar.
It's just like
Oh, it's
you
frozen?
divide 14 by 2 and you get 7.
Yes.
So it's like, what's it? What's that word? I don't know what it's called.
Angles need to be congruent. And the corresponding sides have to be in the same ratio, which is why Kate said, what did you say, Kate? 14
Divide
divided.
14 by 2, you get 7.
Divide 14 by 7, you get 2. Divide 6 by 3, you get 2. So the scale factor here is 6 over 3, 2 over 1, 14 over 7 equals 2 over 1. Right?
Mm-hmm.
Now think about this. Let's make up a number for the third side. Make up a number that could be, what number shall we make up?
4.
Shall we make it isosceles?
Yes.
And so this would be 6. Right? So now we have two similar triangles. Go find the perimeter of each one. So perimeter here and perimeter here. What's the perimeter of these two?
13.
13,
26.
26. Okay, so we call this 1 and 2, triangle 1, triangle 2. All right? What is the ratio of the perimeters here? 26 over 13. Okay, using inductive reasoning, what conclusion can you draw?
They're similar.
You already knew that coming in. Okay, let me help you. If two figures are similar, then what can you say about the ratio of their perimeters? What is it the same as?
Their scale factor.
The scale factor. Do you see that? So if two figures are similar, it doesn't have to be a triangle, it can be any polygon. If two figures are similar, in fact, not just polygons, circles are always similar because they have the same shape, don't they? And the radii will always be in a certain ratio. So two figures are similar if their corresponding angles are congruent and corresponding sides are in the same ratio. If that's the case, you have two similar figures, then their perimeters are in the same ratio as the scale factor. We good with that?
Mm-hmm.
Okay. Which means that if I have, again, triangle 1 and triangle 2, and you're given that the perimeter of triangle 1 is, make up a perimeter, 20, and we'll say that's 20 inches. And let's say, and this one seems too bigger, so we'll make this 80 inches. We'll say the perimeter of this one is 80 inches. If they are similar, then we can call this perimeter 2, perimeter 1. What does this figure also give you? What is this the same as? Starts with an S. Scale factor, right?
Mm-hmm.
Okay. So now think. You know the scale factor is 4 to 1. If this side is 7, what will this side be?
Oh, 4 to 1, sorry.
4 to 1.
28, yeah.
28. Do you see how that helps? You don't need to know all the sides, etc. So this is 28. What if you have now 2 triangles and you are given that the perimeter of this one is 30. You want to find the perimeter of the other one, and you know the scale factor. So let's make up the scale factor. 3 over 2. So what you want to do is you want to find the perimeter of this second triangle. You are given that the 2 triangles are similar. Yes, ma'am?
Would you multiply 30 by 3 over 2?
I want to say yes, but I'm not 100% sure. I want to say yes. That seems intuitively to make sense to me. So I'm just going to revert back to my formula, because remember, and the scale factor is 3 to 2 means, and if we rely on the drawings, this means this would be 2 and this would be 3. Yes? So if I write my formula down, I have to make sure I write it in the correct order, because P2 over P1 equals 3 over 2. Do you agree with this? Because we found out that the ratio of the perimeters is the same as scale factor. Are you good with that?
Yes.
Yes? And then, which one do we know? 30?
Yeah.
So we plug in here, P2 over 30 equals 3 over 2, right? So what do we do to both sides now? So can we give a round of applause for Kate, who figured it out intuitively? Yes? Okay, so do you see the beauty of this? You can find the perimeter of similar figures even if you don't know all the sides. So in conclusion, if 2 figures are similar, their perimeters are in the same ratio as the scale factor. Inductive reasoning. What do you think the ratio of the areas will be, girls? Okay. Now I'm going to make up another polygon. So let's make up a rectangle. And we'll say these 2 rectangles are similar. Let's make up some measures. So we'll say this is 2, and this is 10, and this is 5, and this is 25. So what's the scale factor here, folks? Is the scale factor 5 over 2, or is the scale factor 10 over 2?
10 over 2.
10 over 2. This is a mistake many of you make. When finding the scale factor, you go from one figure to the other. And you also keep in mind, are you going from the smaller to the larger, or the larger to the smaller? So here we'll go larger to smaller, 10 over 2. And that gives us 5 over 1. And 25 over 5 also gives us 5 over 1, right? So we've got 2 similar rectangles. Find their area quickly. Go ahead and find the area. So we'll call this 1 and call this 2. Area of 1 equals, and I'll do it over here. You can do it very quickly on your calculators. Well, you really don't need calculators. 10 units squared. Area 1 over area 2. So girls, on this side, if I have area 1 over area 2, the scale factor here, should it be 5 over 1 or 1 over 5?
1 over 5.
Macarena is absolutely correct. It should be 1 over 5 because we are going from smaller to larger, right, ladies? So 1 over 5. And now all I have to do is plug it in. Just for consistency, let me change this to 1, 2. So I've got 10 units squared, and the units will cancel out. Equals, does it equal 1 over 5, girls? Let's just see what it equals. What does it equal?
1 over 25.
Well, what do you need to do to 1 over 5 to get 1 over 25?
Multiply by 5.
Multiply by 5. Should we multiply in the numerator or the denominator? How should we do that?
Denominator.
Denominator. Would you agree this is 1 over 5 times 1 over 5? Yes? So, we can conclude by inductive reasoning again that area 1 over area 2 is equal to 1 over 5 squared. And since this is the scale factor, we can say it is scale factor squared. In your textbooks or in textbooks, you will see that the scale factor is stated as A over B. So they'll put it this way. They'll say this is A over B.